Today we're going to continue on with Chapter 11, 11.5, calculating the volume of pyramids and cones. And today we're going to talk about the two pointy shapes, pyramids and cones. And then I'm going to also show you a graphic organizer that you can use to find the volume for all 3D shapes except for spheres. That would be pyramids and cones, as well as prisms and cylinders. All right, so today's objective is that by the end of the day, you will be able to find the volumes of pyramids and cones. Let's quickly talk about pointy shapes. And I want to make this clear. If you were to look at a geometry textbook or go on Google and say geometry, what's a pointy shape, you wouldn't find this. This is what Mr. Hayes calls them. This is just a Mr. Hayesism, but I think it makes sense to try to divide the shapes into pointy shapes and non-pointy shapes. So prisms and cylinders, if you remember, have two parallel bases. They don't end at a point. So on the top there is a prism, on the bottom there is a cylinder. But pyramids and cones have only one base, and then each point on the perimeter of that base is connected to a single point called the vertex. So right there, you can see that. So again, the pyramid comes up to the point at the very top there called the vertex, and the cone is the same way, while you notice that the prism and the cylinder don't have that pointy shape. Okay, let's now that we've defined pointy shapes, let's look at the volume of pointy shapes compared to the volume of the non-pointy shapes. So here in this video, we have on the left is a pyramid and on the right is a prism. They have the exact same size base and the exact same height. So before we play this video, I want you to imagine what you think how many of the pyramids are going to have to get filled up and poured in to totally fill in the prism. In other words, how much smaller is a pyramid than a prism if it has the exact same base and the exact same height? All right, so let's do that. Let's watch that movie and see.
So first we're going to fill the pyramid to the top. There's one. We're going to pour it into our prism. And we're going to fill it up 2 more times. As you look at the prism, you'll notice it is approximately 1/3 of the way filled. Once we fill it up with this one, it should be approximately 2/3 of the way filled. Still some in there. Alright. And one last time. And you will notice that the square prism is filled to the top.
Let's do it again. Let's watch this same movie again, except now the exact same base is a circle and the height is the same. So we're now going to do the same thing comparing a pointy cone to a non-pointy cylinder.
Once. Twice. And 3 times.
So these videos and these examples should lead us to the rule of pointy shapes. And again, please don't Google it because you won't find it. This is a Mr. Hayesism, but I think, again, it makes sense to try to look at it this way. So to find the volume of any pointy shape, first multiply the base by the shape's height, just like you would do if the shape wasn't if the shape wasn't pointy, if it was a cone, if it wasn't a cone, if it was a cylinder, or if it wasn't a pyramid, it was a prism. You just multiply the area of the base times the height. Then you use the rule of pointy shapes, and if it's pointy, divide by 3. So the formula that I tend to use is simply this, that the volume of a pointy shape equals the area of the base times the height, and then divide the whole thing by 3. However, I know some of you like to have specific formulas for each one, so let's do that. So in our notes, we have what is a volume. Of course, the volume is the number of cubic units that fit inside a 3D figure. And then we have the volume of a pyramid. So that's just the base times the height divided by 3, or 1/3 base times height. Or, again, we can just call it the area of the base times the height over 3. For a cone, the formula is, again, 1/3 base times height, except the base is a circle. And of course, the area of a circle is pi r squared. So it will be 1/3 pi r squared height. Or the area of the base times the height divided by 3, same thing. Or pi r squared times height divided by 3. Once you get these down in your notes, try the next 3 example problems, 1A, 1B, and C. Try them on your own, and then you can play this video to see how you did. Problem 1A is asking us to find the volume of this square pyramid, and we know that the volume of a pyramid is equal to the area of the base times the height and then since it is pointy, it comes to this vertex right there. It's pointy, so I divide by 3. All right, so the area of the base, let's draw the base so we can see it. It's this square here that's 8 inches on a side. All right, so the area of the base, whoops, is just equal to base times height, which is equal to 8 inches times 8 inches, which is therefore equal to 64 square inches. That's the area of the base. The area of the height is, or sorry, the area, the length of the height I can see is this line right here. It goes from the vertex to the base, and the key thing is that it is perpendicular to the base. From this right angle sign right here, I can see that it is perpendicular to the base, and of course the height is always perpendicular to the base. So the height, it just gives it to us right here, is just 10 inches. So now I can plug in my formula for my volume. My volume for a pyramid is equal to the area of the base, which is 64 square inches, times the area of the height, or so it's times the length of the height, 10 inches. And that whole thing we're going to divide by 3. So when I do that, I get that that's equal to 640 cubic inches over 3, which if I divide that, that's going to be equal to 213.3 repeating cubic inches, and it wants me to round to the nearest tenth, so the answer would be 213.3 cubic inches. This problem, 1B, is asking us to find the volume of this square pyramid. So the volume of a pyramid is equal to the area of the base times the height and then that whole thing, because this is a pointy shape, it comes to this vertex right here. Take that whole thing and divide by 3. So first, let's find the area of the base. Let's put that area on. Let's draw it first. This is what the base looks like. Like here, there's one side, 2, 3, and 4 sides of that base there. And the area of that base is just going to equal base times height, which is going to equal 1.2 centimeters times 1.2 centimeters, which is going to equal 1.44 square centimeters. So there's the area of the base right here. Now we need to find the height. Let's draw it first. I'm trying to find this shape right, the height right there, which goes from the center of, from the vertex to the center of the base. And I don't have that, but what I do have is right here, I have this slant height. That is the height of the triangle on the outside that makes up this shape. And if I draw the line between them like this, that makes a right triangle. And if this entire side from here to here is 1.2 centimeters, then I want half of that. So from here to here, that would be 0.6 centimeters. So let me redraw this triangle over here so we can see it. There's my height, there's my slant height, and there's half of the line for the base, and this is a right angle. So again, this is my height, this is my slant height of 2.8 centimeters, and this is my part of the base, which is 0.6 centimeters. And this is a right triangle. So like any right triangle, a squared plus b squared equals c squared. Our Pythagorean theorem holds. If I make this side a and this side b and this side c, then I've got h squared plus 0.6 centimeters squared equals 2.8 centimeters squared. So that would be h squared equals, h squared plus 0.36 square centimeters is going to equal 2.8 squared would be 7.84 square centimeters. If I subtract 0.36 from both sides, and subtract those, this cancels. So on the left-hand side, I'm left with h squared. On the right-hand side, I'm left with 7.48 square centimeters. And so now if I just take the square root of both sides, the square root of h squared is h. The square root of 7.48 is just the square root of 7.48. And the square root of centimeters squared would just be centimeters. So now I have my height here of square root of 7.48 centimeters. So now I can solve the problem. Now that I have all the information that I need here, I know that the volume of a pyramid is equal to the area of the base, which as we just said here is 1.44 square centimeters, times the area, or something, times the distance of the height, which is in this case square root of 7.48. It's going to be centimeters. And I'm going to take that whole thing and divide it by 3. And when I do, I put it into a calculator, I see that is about equal to 1.3127, and obviously it goes on and on forever and ever. And that, of course, would be centimeters times square centimeters would be cubic centimeters. And this problem is asking us to round to the nearest tenth. So that would just become that this is about equal to 1.3 cubic centimeters. This problem is asking us to find the volume of this cone, and the volume of a cone just equals the area of the base times the height and that whole thing we're going to divide by 3. The base, whoops, not quite, let's try one more time. There's the base like there. Okay, and it's got a diameter going across it right here, which is 14. And if we want to get the area of the base, like any circle, that's just going to be pi r squared, which is going to be pi. If this whole thing is 14 across, half of it from here to here would be half of 14, or 7 feet across. And we want to take that squared. So put that all together, and that is 49 pi square feet. I also need to find my height. And my height is given to us right here. It goes from the vertex to the base, and it's perpendicular to the base. So I know that's my height. So my height is equal to 24 feet. So now if I just put these all together, the volume of the cone is equal to 49 pi square feet times 24 feet. Take the whole thing and divide by 3. And if you do that, you get that that's equal to 392 pi cubic feet. I have created for you a graphic organizer to help you find the volume of pyramids and cones and prisms and cylinders. So everything that we have except for spheres. And to do this, you follow these 4 steps. So we'll do a couple of example problems so you can see how to do these. All right, so the first thing I have to do is, it says step 1 is to ID the shape of the base. So when I look at this problem 1, hopefully we can see that this base is a triangle. So I'm going to click on triangle here, and then I'm going to use that entire row for calculating the base of a shape with a triangle as a base. Now, the next thing I have to do is calculate the area of that base. And of course, for a triangle, the area is 1/2 base times height. So I've got my base is 4 and my height is 3 on that triangle. That's 12, take 1/2 of that, that is 6. So the area of the base is 6. Now I want to multiply that by the height of this shape, which is also 6. You can see that 3, 4, 5 triangle on the left and the right and the way it's drawn here, and then that 6 meters is the height that separates those two bases. So the height would be 6. Now it's asking me to multiply the area of the base times the height, so 6 times 6 would be 36. And the final question is asking, well, is this shape pointy? If the answer is no, then you're done. If the answer is yes, then you need to divide by 3. So for this one, when I look at it, I can see that the answer is no, this is not pointy, so I'm done. The volume of this shape would be 36 cubic meters. So this problem here is asking us to find the volume of this cone. So first of all, I have to identify the shape of the base. In this case, it is a circle. Next, I have to figure out what the radius is, and if the diameter is 12 kilometers across, then the radius must be 6. So to calculate the area of the base, that's pi r squared, just pi times r, so pi times 6 would get me 36 pi. Now, what is the height of that shape? Well, the height of it is 12 kilometers, so I'm going to put 12 here. And now I'm going to multiply those two together. 36 times 12 would get me 432. So it would be 432 pi cubic kilometers. That's if it were not a pointy shape, if it were a cylinder. But when I look at this one, I can see, yes, it is a pointy shape. It's a cone. The point is down at the bottom. So I need to divide by 3. When I divide this by 3, I get the answer is 144 pi cubic kilometers, and that is my final answer.